Okay, today we are learning about the sine and cosine graphs for the parent functions and what the graphs look like after they have had a variety of transformations applied to them. So in doing this, I would really recommend that you have out two colors of highlighters or two colors of pens and then your pencil. I'm going to be using color to do several different things. All right, so let's discuss. Sine and cosine have a domain of all real numbers. They extend forever in both directions from negative infinity to positive infinity. The range of each parent function is from -1 to 1. So they have a minimum, they go down to -1, and a maximum, their highest value is 1. Okay, we're going to learn today about amplitude. So amplitude is half of the distance from the max to the min. So the amplitude is half the distance from the max to the min. Okay, we're also going to learn about the period. And so each function is periodic, meaning it repeats. It's called a cycle. So one cycle, the length of one cycle is the period. The parent functions have a period of 2 pi. And if you think about that, that's because every trip around the unit circle is one cycle, and the unit circle is 2 pi. After 2 pi, they repeat again. So the x-intercepts for sine, think about where sine is 0. They occur at 0, pi, 2 pi, 3 pi, 4 pi, then also negative pi, -2 pi, -3 pi, -4 pi, and so on. Now the x-intercepts for cosine, think about where cosine is 0 on the unit circle. That happens at pi over 2 and at 3 pi over 2. Then going around the unit circle again, that's 5 pi over 2 and then 7 pi over 2 and so on, and then also in the negative direction. So these are very much related to our unit circle, which is what we were trying to show you during our lab that we used spaghetti, uncooked spaghetti, to show kind of the relation between the distance on the unit circle to these graphs. So the amplitude, how you find the amplitude is you take the absolute value of A. And what A is when we're in the form of A sine bx or A cosine bx. So A is the vertical stretch or the vertical shrink. That number is what changes the amplitude. It's always positive because it's a distance. The period is found using 2 pi divided by b. B is the number that is the horizontal stretch or horizontal shrink because that's what's going to change the period, is being compressed or stretched horizontally. All right, I think it's easier once you start to see this in person. So graphing the parent function, sine of theta. Okay, so we are graphing, and they can use theta or they can use x. They can be used interchangeably. It doesn't really make a difference. So the midline, so here's my suggestion with having, a different colored set of highlighters. I'm gonna go ahead and highlight the midline yellow. So the midline is where, in this case, our x-intercepts are, but it's going to oscillate above and below this line. So we're going to highlight the midline. Okay, the midline on the parent function is the x-axis, or y equals 0. Now, once we graph it, we're going to put a box around the first period. So the period of the parent function, sine theta, is 2 pi. And that's because, remember, it was the formula 2 pi over the absolute value of b. Well, b is the number that is in the parentheses after sine, like by the theta or by the x, and this did not have a horizontal stretch or shrink, so the period stays 2 pi. The amplitude is 1, because remember the amplitude is found by the absolute of the a value, and the equation of the midline is y equals 0. The midline is only going to change if there's a vertical translation up or down. All right, so sine, if you recall, sine at 0, the sine of 0 degrees is 0. So it starts here. Now I'm going to go ahead and label my graph, and I'm going to say that this is 1, and then this is -1. Okay, so with my amplitude being 1, the other reason I had you grab a different color of highlighter is to be able to go ahead and highlight where your top, your maximum should hit, and where the bottom of your graph or where your minimum should hit. And it's basically going to kind of bounce back and forth between these. Now, it is not a requirement to have these on here, but Ms. Davis and I both address graphs this way. It just helps us remember, where our highest point should be and where our lowest should be. So now I also think about this. I think about the critical points, meaning the max, the min, and the x-intercepts. Remember that a sine graph is going to go like this. That's one period of a sine graph looks like that. So it's going to have an x-intercept, a max, another x-intercept, a min, and back to the x-intercept. So if you picture that, that is actually divided, okay, into basically 4 different places. So I can take our period, which was 2 pi, and divide it by 4. And so I know that our critical points are going to be every pi over 2. So that helps me just easily go, okay, my sine graph now goes up at pi over 2 to 1. At pi it's 0. At another pi over 2, it's down to -1, and back up to 0. And so it's going to bounce like that. I could also make a table and know that the sine of 0 is 0, and think about your unit circle. The sine where it's pi over 2 is 1. The sine at pi is going to be 0 again. The sine at 3 pi over 2 is -1, and the sine at 2 pi is going to be 0 again. Now, we are going to want to draw in, kind of make it curve. We don't want it too pointy. And then we want to continue this on. So it's going to go in that pattern. Once I have that pattern down, I don't continue to make a table. I just continue, and that helped knowing my spacing, that every pi over 2 should be another critical point, meaning either an x-intercept or a max or a min. That just helps me with my spacing. Okay, so that's what the graph of the sine of the parent function looks like. Notice I put arrows on it to show that it extends forever to the left and the right. Now, I asked us to put a box around the first period. So the first period would be right here. At this point, after the green box, it's just going to continue to repeat. It also wanted us to draw in a line segment showing the amplitude and label it A. So here's our line segment, and this is A. That's our amplitude. You can also see our amplitude right here. That's A. Okay, we are taking a lot of time on these parent functions because understanding the parent function is the key to all the other graphs. All right, so the graph of the parent function of cosine, it has the same period. It's 2 pi, and the amplitude is 1, and the equation, the midline, is y equals 0. So just for what we explained nice and slow below about how it doesn't have any vertical translations up or down to move the midline, it doesn't have any horizontal shrinks or stretches to move the period to make it larger or smaller, and it has no vertical shrinks or stretches to change the amplitude. So since I know that it's going to go from 1 to -1, I'm going to go ahead and put my lines in. So I use one color for my midline, and I use another color for my max and min. That's just kind of my process. I went ahead and I'm going to label this that this is 1. You have to label so we know what we're indicating, how big our scale is. Now cosine starts up. Think about where cosine is at 0. At 0 in the inner circle, cosine is 1, because remember it's the x value. Now, this has critical points. Remember you take the period divided by 4. So every pi over 2. So that tells me my spacing. So it starts up, and then at pi over 2, it's at 0. At pi, it's down below at -1. 3 pi over 2 is back to 0, and 2 pi. So it's going to continue like that. So it is very much similar to a sine graph, except cosine starts at 1. And then, if you know your spacing, you can just continue the pattern. You just got to keep your spacing correct. All right, I'm drawing some arrows so we know it extends. And that is our graph of cosine. So the main difference is that sine is going to start at 0, 0. Cosine starts up at 0, 1. Okay, so example 1a, they give us this equation, all right? So I think the most important thing first is to identify the transformations. So it says 4 times the sine of x. All right, so its transformations, this 4 is a vertical stretch by a factor of 4. So a vertical stretch will not change your period. So your period is still 2 pi. Remember, that's changed by horizontal stretches or shrinks. It does change your amplitude. Your amplitude is the absolute value of A. So it's the absolute value of 4. So the amplitude is 4. There were no vertical translations up or down, so the midline is still at y equals 0. So let's go ahead and first let's draw on our midline. And now I need my amplitude to go up 4 and down 4 from the midline. So in this case, this needs to go by 1s so that I have room. So this will be -1, -2, -3, -4. And then once again, I like to go ahead and put my line. It doesn't really show up on a regular graph. This highlighted line just helps me get the spacing right. Okay, now the critical points are going to be, remember you take your period and you divide it by 4. So 2 pi over 4 mean your critical points are going to be every pi over 2. So sine starts at 0, 0. Then it goes up. But instead of going up 1, it goes up to 4 because of that vertical stretch. Then it comes down to the x-axis again, or to our midline. Then it goes down to -4, once again because of the vertical stretch. So it has the same period that the other one had, it just has that stretch applied to it. So then continue your pattern. You want to go ahead and fill in your graph. And then draw it in. You know, we try to be as smooth as possible and not make it look pointy. It should definitely have a curve to it. And then make sure, oops, didn't quite hit that one. Make sure to put arrows on both ends. Okay. So now if we look at 1b, identify the amplitude in the period. So the period, this one did have a horizontal shrink applied to it. So let's look at our transformations first. So here's our equation. All right, so remember that we write horizontal translations first, then we do stretches and shrinks. They don't have an order, they have to be in terms of which vertical or horizontal stretches or shrinks first. So I would say it has a vertical shrink by 1/2. That's going to affect the amplitude. The amplitude is going to be 1/2 or 0.5. And then it has a horizontal, let's see, that would be a shrink by 1/4. Now, sometimes students try to plug in 2 pi divided by 1/4, but it's just divided by the b value, so it's divided by 4, so that means the period is every pi over 2. Okay, and then the equation of the midline, there was no vertical translation up or down, so it's still y equals 0. All right, so here's our midline. Now, if I go ahead and make this 1, then this is 1/2, and so this is -1. And let's draw in our top and bottom where it's going to oscillate between. Okay, now it's important on this one, since our period changed, to think about our critical points. So your critical points, you take your period, which is pi over 2, and you divide it by 4. So I'm going to times by 1/4 instead of dividing by 4. So every pi over 8. So keep in mind that this mark right here is pi over 4. So it has critical points in between there also, okay? So it's going to complete one period from 0 to pi over 2. All right, so this is a cosine function. So it starts up because it didn't have any reflection. If it had reflection, I need to look at it and see where it starts. But it starts up, and then we have our point that is on the x-axis or the midline, and then it hits its minimum, and then it hits the midline, and then the maximum, the midline, and so on. Okay, so this one's going to have a lot of periods shown on this graph. So, not doing the best job hitting those. All right, better get some more points in here. Oops, missed one. All right, there we go. So you can see there's a lot more periods on this space because the period was every pi over 2. So you can see that there's 4 times more periods than the normal amount of just 2 pi. And you can see how much shorter it is, and that's because of our vertical shrink.